Today, I'm going to be talking about some of the security threats and vulnerabilities of VoIP. So basically what I'll be talking about is what VoIP is, how it works and some of the protocols it uses, some of the vulnerabilities and attacks that can occur to VoIP, and finally, what security measures should be put in place. So first, what is VoIP? VoIP stands for Voice over Internet Protocol. It allows you to make phone calls over the internet, and you can do that using VoIP phones, also called IP phones, software on your computer called soft phones or software phones, applications on your phone, and adapters connected to a traditional landline phone, such as the one shown in the diagram on the slide. Um, it uses a variety of protocols depending on which application it's used, but the main two it uses are SIP and RTP to establish connections between devices. So SIP, or Session Initiation Protocol, is an application layer protocol that is used to establish, modify, and terminate multimedia such as internet phone calls. With SIP, you actually can't transmit media between devices, so its main responsibility is to just create the session between two devices. Um, it uses 6 different signaling methods to set up calls. An example of those are invite, acknowledge, and register. SIP also uses the default port of 5060. So right here is an example of a SIP stream. So first the client sends an invite, and then the proxy server responds with trying. The proxy server then looks for who has those email addresses, and once the parties are found, it sends an invite to the user agent server. Um, the user agent server responds with trying and ringing and sends the ringing signal to the client. And finally, the OK signal is sent, and then the two parties are connected once acknowledged. RTP, or Real Time Transfer Protocol, is responsible for allowing media such as audio and video to be transmitted across the network between two devices. Um, RTP uses the default port range of 16.384 and 32.767. So now I'm going to talk about some of the different vulnerabilities and threats. First, we're going to start out with Android VoIP vulnerabilities, and there's 3 I'm going to talk about, which are making unauthorized calls, undeniable calls due to long SIP name, and remote code execution. These were all discovered using a technique called fuzzing. Fuzzing is an automated software testing technique that relies on blasting random and malformed data into a software component and looking for any abnormalities in the output and basically seeing how it reacts. So first we'll start out with making unauthorized calls. So it was discovered that unauthorized calls were able to be triggered using the VK app. The VK app is basically a Russian social networking site that allows you to send messages and make free calls over the internet. The calls are able to be generated from a malicious app that is installed on a device. The calls can also be generated when the phone screen is turned off, so the device owner will have no idea that their phone is currently in a call. And that leads into the next point, which allows eavesdropping on the device owner and other nearby conversations. So if this was in a corporate environment, you could possibly have sensitive information listened on. The next one is undeniable calls due to long SIP name. With this vulnerability, attackers are able to initiate a call with a SIP name up to 1043 characters long. This prevents the call from being denied due to the name filling up the screen, as you can see from the example on the slide. This is also considered a denial of service attack because attackers can keep sending calls over and over and over again and it basically renders the device useless for a certain amount of time. Basically, the only way to stop this attack is to disable Wi-Fi or cellular connection and turn off the device completely. Remote code execution due to stack buffer overflow. This allows attackers to run malicious code on a remote device through a VoIP call. Um, it was determined that a stack buffer overflow can be triggered if a username or caller number in a VoIP call with more than 513 bytes. So now I'm going to move on from Android and talk about a newly discovered malware called CDR Thief. This malware was discovered within the last 1 to 2 years. This malware is unique because it only targets two specific Chinese soft switches, which are LeakNet VOS 2009 and VOS 3000. Within a VoIP network, soft switches provide services such as call control, billing, and management. So the main purpose of the malware is to obtain call detail records, which is where it gets the name CDR Thief. CDRs contain information such as caller IP addresses, call duration, time of the call, and any other information that might pertain to call information. Basically, to obtain the records, the malware queries internal MySQL databases, which are used by the soft switches. These soft switches are also usually run on Linux-based servers. The malware is able to decrypt the passwords that are stored in the configuration files, and the malware can also be installed at any location on the disk under any given name. There is a theory that if this malware continues to develop, it could actually be installed within the boot binaries. So right here is all the configuration files the malware was able to access to get the call record. So next I'm going to talk about eavesdropping attacks. So basically the goal of an eavesdropping attack is to capture voice packets. This can be accomplished using network analysis tools such as Wireshark. The captured voice packets are then able to be converted into a WAV file and stored on the attacker's computer. Basically, in order to do this, the attacker scans for SIP packets within a network, and then they convert these SIP packets into an RTP stream, and they are then able to go back and listen to the recordings that were captured in the RTP streams. So now I'm going to talk about some of the security practices that should be put in place. So the first and most obvious is to set up firewalls and intrusion detection systems. However, if you are using network address translation, you should set up an application layer gateway with VoIP configured. This is because NAT can make a network extremely complicated, and it can be difficult to filter VoIP traffic with a regular firewall because of the way firewalls typically behave. You should also use VLANs to separate voice and data traffic. I know in some places they actually use separate switches for their voice and data traffic. If you have remote users, you should use VPNs to ensure that all traffic is encrypted. You should also perform any security and firmware updates as well as updating any antivirus software. And finally, you should stay up to date on any new potential malware that is being developed, such as the CDR thief. So, in conclusion, attacks on VoIP devices can be a major problem, especially if sensitive information is being stolen, and especially if that happens in a medical setting. You could have private patient information stolen over the phone, um, or you could have sensitive corporate data being stolen. Um, Attacks will continue to increase as more and more VoIP devices continue to come online. Um, More and more businesses are starting to update their old existing digital infrastructure to VoIP infrastructure, which will cause more and more attacks. New malware will be created, such as the CDR thief. With As always with new technology, someone's always going to find a way to find vulnerabilities and attack that. Security measures should always be put in place no matter what, and you should always research for new threats that can occur to VoIP devices, because if you are in charge of a VoIP network, you want to be able to know how to prevent them as well as mitigate them if they do occur. And that concludes my presentation.